Hello everyone and welcome back. So in this video we'll be modeling step by step this procedural pepper. It might look simple at first, but honestly I faced some challenges when trying to recreate this, so it might be worth a watch if you're in the mood. So let's get into it. So I just saved a new scene and I'm gonna start with, as always, with a geo container, creating a line, and I'm gonna center it because it's always a good idea to start from the center. So just pasting the distance divided by 2 and make it negative. Now we have a line with 2 points, and right away I'm gonna increase the point marker size and the point size in here so we can actually see better these points. Now we need some points to play with, and I'm gonna use a resample and set it to 0.05. Now, we could have started with a curve, recreating the shape, and then revolve it. We will still revolve it, but as a challenge, I wanted to try to create this overhang look like we did for the leaf tutorial. So, but this one is a bit more simple, we just need to play with the ramps. So let's get into it. This will involve a bit of vex, but nothing too complicated. So let's output curve view because we will need it. Let's create a wrangle. And I'm gonna save the curve view as U so I can reuse it, and I don't have to type always curve view. Now we're going to create a ramp for the shape. So for the shape we want to deform, so float shape, it will be equal to a channel ramp. Let's call it shape, and we will use the U component to deform it. Now we will create a normal. Let me increase this for you, just in case. Maybe that's too much. So let's create a normal to displace the curve. So vector n, it will be, I'm gonna displace it along the x, so 1, 0, and 0. That's our normal, that will be pointing in this direction. Now, let's actually displace this, so v at p plus equal along the normals, and we want to multiply it by the shape, which uses the curve view, and I also want a displacement multiplier at the end. You will see how this comes together. We have done this plenty of times, but now there's a twist to it that we will get in a bit. So if I increase this, as you can see, it's following the shape of the ramp, and I can shape it the way I want it. But let's see. If we start to create the shape of the pepper, so let's see. Let's set this to hill and set it to B-spline and maybe decrease. But as you can see, we don't have that overhang. I'm calling it overhang. I think that's that curvature that we have going up and down. So for that, we will need to manipulate this normal that we created in here, that vector attribute or variable. So we will need to rotate it. You can use matrices or you can use quaternions. I prefer to use quaternions, and it's pretty simple. You just create a variable called quat or anything else you want to name it, and you type quaternion, and you have to specify an angle, how much you want to rotate. Oops, angle. And you also need to specify an axis. In this case, I'm going to rotate it around the axis facing the camera, so z-axis, so 0, 0.0, 0, 0.0, and 1.0. And we need to define an angle, of course. And the angle will be again a channel ramp of U, because I want to manipulate it along the curve. So let's call this angle and call this angle ramp. So let's create that, and now we didn't rotate, we just created a quaternion. So in order to rotate, we will affect the normal, and we will Q rotate to neighbor. So we will rotate the n. So Q rotate, and we want to use this quaternion that we just created, and we want to rotate from n. So now we see some change, but we actually need to create the angle ramp. Oh, we already have it. So let's expand this and expand this one. And if we start, for example, to decrease this one, and so let's see. did I did this correctly? So rotate around and yeah. So now what we need to do is first of all, let's play in here with this ramp. So let's say we want it like this, and as you can see, it's already going in. And if we manipulate this, as you can see, we're rotating normals along the curve. And if we do something like this and change it to B-spline, and maybe move this one down, we can start to get the shape. So this is the workflow. Now you just need to adjust the ramps. Just to save some time, I'm gonna copy my initial ramps. And they look something like this. So I manipulated a bit more to create these flat areas in here. So you can see my ramps in here. This is the angle ramp. And this is the, I wanted to flatten, this is the shape ramp. I wanted to flatten a bit at the middle, as you can see it, instead of going always bulged out. So let's delete this and continue. Now we need to resample this a bit. So resample. Let me see how much did I use in my case. So subdivision curves 0.05. So 0.05. And let's set this to subdivision curves. Let's create a null. And this will be our base. Now we can simply revolve and make sure we reverse. And I think I used 48 divisions in this case because we will need it for the displacement. So it's not too much, not too little, let's say. So as you can see, we have that shape of the pepper. Now we need to create the displacement. So as you can see, we have computed a UV from this revolve, and it looks like this. So it means that we have a value along the U and V of this mesh that we can manipulate to create the displacement. So in order to manipulate UVs in a point VOP, we need to promote it to point attributes. So let's do split UV seams. And let's promote the point attribute, and this will split the mesh right at the seam of the UVs and promote it to a point attribute so we can manipulate it in a point VOP. I'm just going to subdivide these ones to have more geometry to play with, and from here we will create a point VOP. So let's dive inside, and as I told you, we have the UVs, so we can take the UVs and let's do vector to float and connect the Y component to the CD. As you can see, we have a value going around, and we can manipulate these to create the different sections. So for that, I'm gonna first multiply these. So I'm gonna take the Y component and multiply, and I'm gonna create in here a constant, which I'm going to set to 6. But as you can see, that's just multiplying our value. Now we need to repeat it. So in this case, I'm going to use a sign and make sure we make that absolute. And we also need to multiply it by pi so it respects this value. So let's multiply in here. I think it's in here, and we do, so multiply. Let's do multiply constant because this won't change. So let's multiply constant by $pi. And as you can see, now we have 6 divisions, which we can use to displace our geometry. So let's take these out of the CD and do displace along normal. And we take the current position and displace this by this amount. And if we have a look, and we might need a normal or a soften normals after it. And now we need actually to control this displacement. I'm gonna set it to 0.07. And as you can see, we have already a pretty good result. And the tutorial is over. No, just kidding. We still have a lot to cover. So as you can see, this is also creating displacement in these parts, which I don't want. So I'm gonna go back and get this component, which looks something like this. So it's along the Y in this case. It's the X component, but the UVs are inverted. So I'm gonna take this and I might feed it, but no, I'm not using the feed, so I'm gonna just use a ramp to manipulate it, and then I'm gonna multiply it over. Yeah. So in this case, I'm going in here and multiply this. So we're just controlling how much effects, and make sure we set this to spline, yeah. And now outside we can set a proper ramp. So in this case, I'm gonna set this to heel, set it to B-spline, and as you can see, it's not displacing as much in here, but we can probably manipulate it a bit more. And I'm gonna drag this over, and these over, and drag it even more in here. And we get something like this. So that's our displacement. I don't think we need to do anything else in here. Actually, we do, because we will need to target these points in here. And for that, we can create a custom attribute. So let's have a look at that. Basically, I want to take these 6 divisions and create an index for each section. And I covered this in the last tutorial, but it was in OpenCL. So what we can do is take the UV component we are manipulating, and we can multiply, in this case, multiply by this amount. And if we floor it, I think this will work. So, and now we can do a bind export and export this as index U. Oops, not uppercase. All right, now let's have a look at that. Index U, it will look all over the place because there's values over 1, but if we set it to auto, now we will have random from attributes. As you can see, we will have a value for each section from 0 to 5 in this case. Let's set it like this, and now that we have the displacement and those attributes, we will manipulate this. First of all, I want to soften the normals, and now this is in points. I want to promote this to a prim attribute, so attribute promote. And I'm gonna promote these to primitives, the index U, but as you can see, this average won't help as much. In this case, I think I set mine to modes, which works well for these middle points because I want to target those. And as you can see, it's working pretty well overall. And then after this, we want to fuse because we have an open geometry, because when we did the promotion of the UVs and split UV seams. But as you can see, if we do this before, we will get some problems. One of the middle edges, as you can see, one of the limits, it will be a bit out of place in here, as you can see. And this will create us problems. So what we want to do is first promote and then do the fusing. All right. Now we can simply do a attribute group from attribute boundary. That's a mouthful. And we will set this, let's say, edges. But I'm going to set it to points, not UVs, and go for index U. And this will create a group on the boundaries of the attributes, as you can see, of the attribute in this case. So this will be pretty useful because if we check, let's see, as you can see, our normals are not so great in here. We want to have that division very clear, very sharp. So after doing this, I'm going to create a group by range, and I'm gonna set this to points, and let's name it edges, override the group, edges as base group. And now we want to subtract from the start and the end. But as you can see, this is not working properly because we need to sort our points. So for that, I'm gonna use a sort, and we still have the UVs. So we can sort by attribute, and we have the UV zone as a point attribute, so we can do texture. And as you can see, we have the points being expanded, in this case decreased along the length. So let's do 50 and 50, and we should have this. Because I'm doing this, sorry, not telling you first, I'm doing this because I don't want to affect these parts in here. I want them to stay soft and then just affect those areas in the middle. So the next step would be to displace these points with a soft pick that worked well for me. And let's do the edges. And if we start and decrease the radius, as you can see, we are displacing the edges. Let's do minus 0.006. And let's look, and now as you can see, we have those edges displaced. And if we didn't do this group by range, as you can see, we have, well, this will be covered, but just in case, just as a nice trick, this group by range is always good to know how to manipulate. From here, we can create a simple mountain. So let's do a mountain. And I'm gonna change this to sparse, just to give it some displacement. Noise along vector is fine. I'm gonna set an amplitude of 0.07. I think I'm not using this fractal, just to be a bit more less noisy. And let's set an element size of 0.3 something. And we get something like this. But as you can see, this will recompute the normals. And I still want the normals from these displacements, but what I'm gonna do is to cheat a little bit and create a normal and affect only those points that we still have and set this to 25, let's say. So as you can see, we get best of both worlds. All right, that's our main shape done. Now let's move into the next part. So now we will create this part, this top part in here that like connect the pepper and the stem. So for that, I'm gonna object merge in here with my quick object merge. I've done a tutorial on it. It's a Python script. And we will carve this a bit. So let's do a carve and set this to 0.9. We will just use this part. And let's do a resample. I think I did quite a bit of resample in here. Let me see. So in this case, I'm gonna use segments because I want to target these later, and set to subdivision curves. Now I'm gonna copy this around, copy and transform. And I think I'm gonna use 12 copies, so 12 copies. And now we want to distribute them in a circular way. And that's the advantage of working with geometry at the center. It will make our life much easier. So let's copy these and do 360 divided by the number of copies. And we get this. It's fine. Now we can sweep this, so let's do a sweep, or you can use a skin. I'm gonna use sweep, and I'm gonna make sure I set this to closed. That's fine. Now, I want, if you look at this, as you can see, maybe so as you can see, the geometry is not sitting flat on the pepper, and I want that. So I'm gonna use a workaround in here because doing directly a ray won't work very well because it will deform too much the shape and make it more squared like. So what I'm gonna do is to object merge in here this pepper geometry, then do a ray to this, and let's see, I think I use let's not show. I want the other way around, sorry. And do minimum distance. And as you can see, we will have something like this. And now we can take this, which is more rounded, and do a surface deform. So surface deform. And we will take this both as rest and the geometry to be deformed, and the other one, as you can see, it's a bit more rounded, and it should be sitting very close to the surface, as you can see. So now let's subdivide this once. Let me see if I use something in here. Yeah, I set this to bilinear because I don't want to lose that polygonal shape. At least it was closer to this in my reference. Then, as you can see, when we do the subdivision, in the end we'll start to see the delta of the geometry or the wireframe of the geometry showing up. So what we can do is do an attribute blur and keep the sharp edges. Let me see how much did I use in here. In this case, I use quite a bit. So to get this rounded look, as you can see, and we want to pin border points, of course. Then after this, I'm gonna do, so in this sweep, let's see. We want to create an attribute that we have in here. Let me see if I guess which one it is. I think it's this prim row. So if we do prim row and visualize the attribute, as you can see, we will have an attribute for each section, which will be nice for us because even after subdividing, we still have that primitive attribute. If we do this on points, it won't work as well. So now we're gonna do again a group from attribute boundary. And I'm gonna call this boundary. make sure, I'm not sure if I'm selecting points or verts, edges in this case. So edges, not UVs. I want to do prim row, and don't include unshared edges. I just want to displace these ones a bit. So this will be a bit overkill for what we're doing, but let's do it anyway. So I'm gonna subdivide these now, and of course, we will use these point groups. So from here, we will do a convert line and convert this boundary to edges. And now we're going to do an XYZ dist to get the distance from those curves. So let's disable this, and let's do a simple f at dist, just save as an attribute, and we'll do XYZ dist. Input geometry will be 1, which is the second input, and from the current position. And if we have a look, we have this, which doesn't look like much, but when we attribute normalize float, this is from labs, and it works pretty well, and we do dist. As you can see, we have the distance from those curves, and we want to target these blue lines. So what we're going to do next is to displace this, so attribute wrangle, and it will be pretty simple. So we're just gonna take the current position and displace it along the normal. Then I'm gonna multiply this by the distance, but with a ramp, so I can manipulate the fall off. So this ramp, and in this case I want to target those blue areas which are 0, so I'm gonna invert this by subtracting from 1. And I think I also created a channel float to control the displacement, because it will be too much by default and we don't need that. So let's create that, and if we start to displace, as you can see, we have this effect. And in this case, I'm gonna set it to 0.015 and make sure we compute the normal. So we set a normal in here. As you can see, we are getting that effect, but I want to manipulate it a bit more, so I'm gonna set this to B-spline and reduce the effect. So as you can see, let me see. So I'm reducing the fall off, let's say. So something like this should be fine. Now we add the normal. And we will extrude this. So let's just check if this is staying on the surface. Yeah, but we need to extrude it down. So for that, I'm gonna create in here a poly extrude. And if we start to extrude this, as you can see, we will have all sorts of problems. So let's do point normal and existing and extrude. We will still have some problems. And it's extruding the other way around. I want to extrude it down, but I don't want to invert it. So what we can do is to reverse this. Now it will extrude down, and I'm gonna do output back. And I just want to extrude by about 0.03, something like this. And to have better results, we can actually set these 2 points and attribute blur the normal. So in this case, and let's blur it quite a bit. So I don't want to pin, and I want to blur it by 27, and that will fix some issues. Then we can just soften normals. Did I use soften normals? So something fishy is going on here. Do I? Oh, I need to set in here 2 divisions. But even that is not working properly. So I guess it's working properly. I just need to attribute blur this a bit, so it's a bit more rounded. Let me see. I don't have point normals, so it's on the vertex. Do I need to delete the point normals? So let me see. Attribute delete the normal and soften normals and attribute blur. Yeah, that seems to work. It's strange because in my original scene I didn't have to do this. Anyways, now we have our shape back, and let's create a null. And let's merge this with this. create a null. And this is our shape. Now we just need to create the stem, which again we will create from the main line. So let's duplicate this, Control C, and paste in here. Now we will carve the last point. So just set this to 1 and extract. Then we're going to create a point in a random direction. And how can we do that? So let's do a wrangle. And we can take advantage of a function that Vex provides, which is called sample direction cone, which will create a direction along the cone, along a cone angle, let's say. So I'm gonna set this. You will see in a bit how this works. So we need the sample direction cone, and we will take the current position, and we need to specify an angle. So in this case, let's say max angle. Then we need to specify a seed. So we can use random I at ptnum. And let's also, from the random, create a seed so we can play with it. I think this is the correct way. Apparently not, because random. Let me see what he's saying. So there's something missing here, because I need no, this is correct, radians. Oh, sorry, I need to create a parameter. And now if we set a max angle, let's say of 60, and look at the normal, and we can play with the seed, as you can see, and we have a random direction. It's always a nice trick to know. So now we need to create another point. So for that, I'm gonna compute in here position for the point. So it will be from the current point position plus the normal. So move it along the normal, and by a specified distance that I'm gonna set. So let's create that distance, and now we will create the point. In point, it will be equal to add point, and we will add to the current input, and the position will be this position. Now we have 2 points, and we need to drag it, and as you can see, it will be along the normal. And I'm gonna set it to 0.4269. That's the value I used. So around this. Now we also need a normal to displace this. I'm gonna create a line from this, so let's do that first. So let's add prim to the current input, and we want to create a polyline, and from the first point, which is ptnum, to the second point. And now we have a line. And as you can see, we don't actually have proper normals. So what we can do is just make sure we set, in this case. So what we'll do, we need to set the point normal. So let's do already the new normals that I'm going to create, which will be pointing in this direction. So we can do a simple, make sure we normalize, because we're going to do a cross product. Cross between the current normal that we defined in there, and with the x-axis, I believe, no, with the z-axis. And let's do 1.0. And let's see, normalize. We need another one of these. Right, so cross, sorry, this is the correct way. And now if we assign, so v at n, it will be equal to n, and we will have the normals like that, pointing in that direction. And we also need to set, for this point, we need to set a point attribute, set point attribute. And we will set to the current geometry, we will set the normals, and for that specific point we created, and we want to set the value as n. And now we have the normals. So quite a bit of work just to create a curve, but then we can use this information to manipulate it. So let's do a resample and go for 0.05. And from here we can do a soft pick. But as you can see, this will displace everything. So we want to constrain to the middle point. So we can do endpoints. not point, n points, number of points of the current input divided by 2. So n points. And as you can see, we have the displacement. And we can play with the radius and with the fall off and displace it a bit more or less. So let me see what sorts of value did I use in here. So 0.11 and set this to 0.231. And I think I set this to quadratic. Yeah, that works better. Now we will delete those normals. Attribute delete, because I don't want to feed that to the sweep, which will be on round tube. And I just need to manipulate the shape and we will be done in a bit. So 12 columns. We still have to do something, but it will not be too much. So let's set this radius to 0.15 and apply in here some scale along the ramp. And I want to take this one to almost closed, and I also want to, let's set this to B-spline, and I want to do something like this, but maybe increase this a bit more. So let's actually see. So something like this, and maybe reduce this a bit more, maybe a bit more, and let's do grid. But I don't want this rounded shape, so let's scale it down. That's fine. And now we will displace this part to be like broken or cut in this case. So let's create some normals on the points so we can blur them. So attribute blur, and I'm gonna blur the normals. So n, and let's blur this by 18. It would be more than enough. And get this weird shape, and let's do a mountain. It should create the correct normals, I believe. And in this case, we just want to affect the end cap, so we need to save in here. Now let's go and change the end caps. And you really have to play with the values. In this case, I'm going to input what I use, so 0.021 and an element size of 0.04. And you can play with the offset and get a different result. In this case, I use 6.45. So something along those lines, and then we can simply solve the normals. Oh, how is it the wrong key? Let's set this to 12. Okay, that's fine. Now let's merge these with this. Create a null. And here is our paper. So guys, that's basically what I had for today. I hope you really enjoyed this one, and if you learned something new, please feel free to leave a comment. And as always, you can grab the sync files from my Patreon alongside with exclusive tutorials like this and even more in-depth, more advanced topics. And you can get all the project files in there. So thank you for watching, and I guess I'll see you next time.